As we talked earlier, there's been work going on within the RIST group to add additional features. And so whilst the core of RIST is quite stable and reliable, there's some new things to talk about.
So thank you, Brad, and welcome to our audience. Again, I'm Wes Simpson, founder of LearnIPVideo.com, and Ciro is the Executive VP of Technology for Cobalt Digital. So I think our most important roles, though, is that I'm the co-chair of the RIST activity group within the Video Services Forum, and Ciro is the president of the RIST Forum and spends a lot of time working on standards, and he's also the author of our documents for the RIST activity group. So he certainly has been a major contributor to all the things, and probably one of the largest contributors, if not the largest, of all the RIST specifications that are out there. So we're going to start out, just do a really quick review of the RIST Simple and Main profiles. We're going to talk about the benefits of the Advanced Profile, and then we're going to dive into a deeper overview of the functions and features that the RIST Advanced Profile is providing, and we'll talk a little bit about future directions. So Simple and Main profiles, they've been out for a while. As you can see from this timeline, the RIST activity group has been in existence now for over 4 years, which is a shocking amount of time to me. I can't believe it's been that long. We've done some multi-vendor interops. We published the Simple Profile in October of 2018. We published the Main Profile in March of 2020. And we've essentially completed development of the Advanced Profile as of this conference. And we expect to have a document out within the next 4 to 6 weeks. So that will be another major milestone for us. Really looking forward to making that happen. And just to refresh you about the RIST profiles and levels, again, this was a document that we published as a support to allow people to understand that not every device has to implement every chapter and every verse of every RIST specification. So there's a RIST Simple Profile that gives you your basic ARQ, supports multiple links, supports bonding and striping and load balancing and all those other good things. When we went to the Main Profile, we added bidirectional tunneling. Another big step up was adding 2 different types of security, both DTLS and pre-shared key. Those are both very valid encryption technologies. They have different applications, but they are extremely important for anybody moving valuable content over the public internet. And then the full level, of course, supports all of the features within the RIST Main Profile. So enough about that. Let's talk about the Advanced Profile. So the main reason we decided to keep pushing with this is that we felt that there were some things that we were off to a good start with in the Main Profile and in the Simple Profile, but we needed to do some things, particularly in the area of tunneling, okay? And our goal was, which we have achieved, is that you can tunnel literally any protocol through a RIST tunnel securely, meaning with encryption, and reliably, meaning with error correction. So the ARQ function can be implemented literally for any protocol that you can think of that we can push through the RIST tunnel. We've also enabled transparent fragmentation. And the reason we did that was primarily because you have to be careful about your packet sizes getting too large. The existing network-based fragmentation schemes don't really work that well. This is fragmentation done strictly within the entry point and the exit point of the RIST tunnel, so that it's transparent to the devices on either side, unlike, for example, IP fragmentation, where once the packet is fragmented, it remains fragmented all the way to the receiver, and the ultimate destination has to put the fragments back together. In this case, we are making our fragmentation totally transparent so that even if we do have to chop a packet up into smaller ones, we can still get those transported. And of course, we will allow you to recover errors on either a full segment or a fragment of a segment. So that's always good. And then we've also introduced mathematically lossless compression. Again, completely invisible, completely transparent to any of the devices outside of the tunnel, but it does allow significant bandwidth savings for a lot of the popular types of media formats that are being sent over RIST tunnels. So not a single bit has changed, and you achieve a great deal of benefit in terms of reduced bandwidth. We've also beefed up our pre-shared key security. We've introduced some new ciphers. That's always a moving target. There's always new and better things coming out, and we decided to add some new ones. And we also decided to include payload hashing, which gives better data security. And Ciro will go into a little bit more detail about how that hashing works and why we ended up doing it. Then we also decided to add in direct payload transport so we could more efficiently transport protocols that we know about, things like ST2022 and ST2110, without having to go through all the headaches of taking those RTP packets, putting them in UDP, putting them in IP, going down to the Ethernet level, and then trying to tunnel it. We can directly transport those with a vastly smaller amount of overhead, and we have established a protocol registry that will allow people to have interoperability and be able to signal how these individual protocols work. And finally, we have flow attributes, which is a better way to describe exactly what's going on inside of a particular flow of packets. So the idea here, again, with the bidirectional tunneling, is that we have an RTP tunnel. So it's very low delay. We have packet recovery, so it's very reliable. And we have security so that all this information is encrypted. And you can see all of the different types of protocols that we can push through this tunnel bidirectionally. Even unidirectional flows can go through this tunnel in one way or the other, or both ways simultaneously. So when you think about it, this is probably one of the best ways that you could envision to take a live flow for ST2110 wide area network application, or something that's been compressed with JPEG XS or what have you, bundle it all together, put it in a very reliable, very secure tunnel, and move it from one location to another, along with all of the supporting signals, your intercoms, your NMOS, anything else that you need to get between two locations. So, we have the bidirectional data flow. We have reliable transport with ARQ and FEC as well. You don't have to use ARQ. You don't have to use FEC. You can use both of them if you want. RIST will therefore support any existing protocol that we've been able to identify. We have the secure transport, again, supporting both pre-shared key and DTLS, so that we can authenticate, so we know who we're talking to. We can authorize who has what privileges, and we can ensure that the data isn't corrupted along the way. And we can do all this through a single UDP port, so that it makes it vastly easier for you to configure firewalls both on the sender and the receiver side, preventing you from having to have half a dozen ports opened up for a wide variety of different protocols going on. So we feel that we've added a lot. We've really enhanced the tunneling. And again, this spec should be out fairly soon. So I'm going to switch over to Ciro and allow him to dive into a little bit more detail about these specific features.
Thank you, Wes. And I promise I will not bore you with packet headers and bits and things like that. We're going to stay high level on this. Don't want to put people to sleep. So how are we doing all these marvelous things that Wes is talking about? So we started with a base packet format with RTP. So everything is running out over RTP. And we aligned that with the work being done with from the ST2110/1 activity group. So as was said before, we are moving in the same direction. That had includes an extension for 32 bits, which you have to have for high bit rate. And we decided on a 1 megahertz timestamp for precise timing. And we added a whole bunch of optional fields to support enhanced functionality. But those fields may or may not be there. So it's quite compact. So the RTP payload then is an encapsulated tunnel packet or a control packet. We design a control protocol for that. What can you encapsulate in this tunnel? You can throw the usual IPv4 packet, IPv6 packets. We had a reduced UDP header on main profile that goes in. There's a control packet that makes this all work. There's a direct payload packet, for which we have a registry. You can throw in a layer 2 Ethernet frame or GRE packets. And we made a distinction between the generic GRE packet and the specifically main profile GRE packet. So all of that can go in the tunnel. Fragmentation. One of the problems with IP fragmentation is that you fragment the packets and they go over the network fragmented, and then it's the other side that puts them together. It's messy and permanent. What we wanted to do is provide ARQ for fragments, because in IP fragmentation, if you're missing a fragment, you have to sit there and wait and time out. And in fact, that's a denial of service attack that people sometimes use. So we can do a fragment level ARQ, and you make sure that that packet is fully reassembled, and then you give the packet reassembled on the other side. The tunnel user is none the wiser. The packet just flows. And one of the important things is jumbo packets that usually the internet doesn't support, but we can support here. So and the fragmentation is actually a lot simpler because you do reordering before. So the mechanism is very simple. It's actually derived from what was done in the add insertion over SDI, the SCSI 104 over SDI, exactly the same mechanism. You just use two flags. Lossless compression. This is not the video compression, is the compression that gets exactly the same bits. Since we're doing this, we added that. You're not going to compress a transport stream. It doesn't compress very well, but you can compress other types of data in the tunnel, and that's very useful. So we defined LZ4 compression, can be used in any packet. It can reduce bandwidth depending on the content, and we left an out in the future. If you design the next greatest compression algorithm, it can be plugged in here using something that's similar format as IP compression. As Mr. Ackerman, our chairman, says, the Lego approach. We just use what's in there. As far as PSK is concerned, the main profile only had AES CTR with no hashing, which is a fine cipher, but there's other stuff out there. So we added both hashing and other ciphers. And why are we doing that? Hashing is for data integrity, and other ciphers because some of these have silicon support in CPUs or are simpler or less load. So you now have a palette of choices for the cipher. And talking about hashing for data integrity, PSK systems based on AES-CTR can be vulnerable to malicious packet replacement or corruption. So we added hashing in advanced profile to prevent that. It's not it's not something that is a great danger, but it's important to have so you can verify that the data is what you think it is. Finally, direct payload transport. Since we have all these tunnels, all these things, why not map directly the data inside the tunnel. So we can use it, this will reduce the overhead, can use as a NAT. And another driving force that's not obvious is you can use that as low latency multiplexing for audio and video. One of the companies that participates in the AG brought that in, saying, hey, I don't need to use a transport stream now. I don't need to incur the overhead of muxing a transport stream. So I can map directly. Now, for that, you need a unique registered payload ID for the packet type. Protocol registry. We have, so if you have an ID, it needs to be registered somewhere. And we decided to go for an open database. It is a registry currently maintained by the VSF. It's hosted on GitHub. It's not public yet. It's there, it's working, but it's not public yet. So we'll launch that once TR-06-3 is approved. At this point, it's pretty much just myself and a couple others and Brad Gilman that have access to that. This is how it looks like. I don't expect y'all to be able to read this. If you can read this and follow it, you're better than me. But it shows you we've had a number of code points already registered and a whole procedure. So this is ready to launch. As soon as TR-06-3 goes out, the registry is populated and the more important formats are all there.
So Ciro, if I may, just to go in the registry a little tiny bit more detail. One of the things that I found was really clever is that each code point is based on a standard that exists in the industry. So if you have an IETF standard, you use the number from that and possibly a flavor, and you register that. If you have a SMPTE standard, you use the SMPTE standard number, and all of those bake into a 32-bit number sort of algorithmically, and you end up with a tremendous amount of flexibility in terms of having a very large space available for identifying these different payloads without tying our hands in the future and saying, geez, I wish I had a code point between here and there. Every time SMPTE comes out with a new standard, it could become a new element in the registry just very automatically. So just wanted to throw that in there.
Yeah, I think this was well designed. You code the standards organization and the standard number, and if there is a part or subpart, you code it in there. It's all described in the TR, which you all be able to read once we approve it. The next thing is flow attributes. This is like a pattern PMT in a transport stream. We came up with a standardized JSON schema where you can label the flows, and that's independent of things like the direct payload. You can describe what the flow is, and that's important. For example, if you have a video, multiple audios, those audios may be different languages, but the same format. So you know what goes together with what, and you have human readable descriptions of that. You can even put in an SDP file if you have that. So it's quite similar to PAT, PMT, SDT in the transport stream, but it's written in JSON. So it's quite easy to pass in, it's human readable.
So I wanted to just take a couple minutes and talk
Sure.
about the future direction. So let's talk about TR-04. So again, TR-03, which is the advanced profile, hopefully by the end of 2021. TR-04, we've decided to divide that into parts that will be possibly released independently. We're not going to try to get all these done before we start publishing some of these. Part one, receiver synchronization. So if you think about a video wall where you want to have multiple different flows all synchronized, that's what part one does. Use of WireGuard. WireGuard's a very popular VPN type of technology, And again, that can be layered right on top of RIST. And the reason for us to write a spec about it is so that we can have compatibility, again, between all the different participants in the network. Firewall traversal, that's kind of a tricky thing. And this is really what we're calling the RIST relay. We've been spending actually the last few months working on that pretty heavily, so that we can have an entity in the middle where two endpoints that are behind one-way firewalls can actually join that and be able to communicate with each other. It's kind of a way to allow very high levels of security at both the sender and the receiver, but still allow them to deliver high performance video between them. And then of course we have control and management for RIST systems. Work is getting started on that. How do we make this more of a system rather than just a point-to-point thing? And then we have some new things to talk about. Congestion control. We want to be able to work out when when networks are overloading and have a way to adapt to that. That would sort of be coupled, if you will, with adaptive encoding. So if you don't have enough bandwidth, you tell your encoder to turn down the bit rate a little bit. Automatic configuration, so that two RIST systems can exchange parameters and look at the network and figure out how they're going to talk to each other. Internet satellite hybrid model. I know that's a favorite of some of our friends at the networks. How do we deliver packets reliably over very diverse networks? And then an IGMP listener, so that we can do things with multicasting that we couldn't do before. So this list is going to change. It'll evolve and grow and things like that. But it's just giving you an idea of where we're heading with RIST once we have TR-03, the advanced profile, published.
Yeah, when it says nearly complete, means the technical work is done. The AG is happy. It's just me having to write it. I haven't done it yet.
Exactly.
Who's behind?
Yeah. So just real quick, who's doing all this? Well, we've got, of course, the Video Services Forum. You're all familiar with that, being here at the meeting. We have the RIST Activity Group. Rick Ackermans is the chair of that. I'm the co-chair, and Ciro is our document author. And we've produced a number of RIST specifications. Those are available to anybody to download free of charge with the very open license that we have associated with those specs. Then the RIST Forum is made up of a group of us that are very involved in trying to promote the use of RIST in the industry, trying to provide information. We just had a user fest about a week and a half ago. The video for that's just been posted on the VSF and the RIST Forum YouTube channels, but that is about a dozen different case studies of how RIST is being used today. So I encourage everybody to take a look at that. And then here's a sampling of the RIST Forum members. This list keeps growing. I'm trying to remember where are we count-wise now, Ciro? We're up in the 100.
Close to 150. We don't fit anymore in a single slide. The slide was for months ago.
Yeah. So RIST Forum is available. For people to join. There's several different tiers of membership. We meet a couple times a month, and we would welcome anybody who wants to participate in the commercial and marketing aspects of RIST.
And that's our presentation. If you have questions, you can ask them out, or you know where we hide.